Hello dear student, in previous lecture we have seen some basic definitions related to complex analysis. That means we have seen some uh, basics of the complex analysis. So today in this lecture we will see complex integration, some parts of the complex integration. We have seen definition of the complex integration and line integration and one result in previous lecture. So in this lecture we will see some basic problems on a complex integration. So in this lecture we will see some problems on a line integral, complex integration, and also we will see some problems on a result that already we have seen in previous lecture. So this is the complex integration definition we already seen in previous lecture. Also we have seen line integral definition in previous lecture. Okay, and also we have seen, so this is the important result in previous lecture. Now we will see some problems on this result uh, in this lecture. Okay, so what is the first problem? So let gamma is any curve which is defined in a which is given in a complex plane C. So let gamma 0 to 2 pi tends to C defined by gamma of t equal to e raised to power it, where f of z equal to 1 upon z, z is not equal to 0, then you have to find out integral over gamma f of z dz. Okay, so here we have given a curve gamma of t which is equal to e raised to power it, where t lies between 0 to 2 pi. So because here t will lies between 0 to 2 pi. Okay, and f of z function is given as f of z equal to 1 upon z, where z is not equal to 0. So here we have to find out the integral over gamma f of z dz. Okay, solution. So what is the given? So we have given gamma 0 to 2 pi tends to c, which is defined by gamma of t equal to e raised to power it. So here t lies between, so here t lies between 0 to 2 pi. So here t lies between 0 to 2 pi. Okay, 0 to 2 pi, 0 to 2 pi. Okay, so here f of z also given as 1 upon z, where z is not equal to 0. Okay, so now integrating over gamma on both sides with respect to z. Now we will take the integration on both sides over curve gamma with respect to z. So integrating on both sides. So integral over gamma f of z dz equal to integral over gamma 1 upon z dz. Okay. So here we will take the integration on both sides. Okay. So integral over gamma f of z dz equal to, so integral over gamma 1 upon z dz as it is. Okay, now we will put z equal to gamma of t, because z along the curve. So in this definition we have seen the variable z transfers along the curve gamma from gamma of a to gamma of b. It is called as a Riemann-Stieltjes integral. So using this concept, we will put z equal to gamma of t. So integral over gamma 1 upon gamma of t into dd of d gamma of t. So instead of z we will put gamma of t. Okay. So here curve will becomes 0 to 2 pi. Okay, t lies between 0 to 2 pi. So we have given gamma lies between 0 to 2 pi. So this integral will become 0 to 2 pi 1 upon e raised to power it, derivative of e raised to power it. Okay, so we have given gamma of t. Gamma of t is, what is gamma of t is? E raised to power it. So put the value of gamma of t equal to e raised to power it. So therefore 1 upon e raised to power it, derivative of e raised to power it, and t integral is t lies between 0 to 2 pi. Okay, so integral 0 to 2 pi as it is. So we can take upper side, so this can be written as e raised to power minus it. Derivative of e raised to power it is e raised to power it into derivative of it, that is I dt. Okay, so in this way we can take the derivative of this term, or we can write this term in this way. So e raised to power minus it plus e raised to power it. So this will become e raised to power 0. So this will become e raised to power 0, and e raised to power 0 means equal to 1. E raised to power 0 means equal to 1. So here written as 0 to 2 pi e raised to power minus it plus it and I dt as it is. Okay, so this is the e raised to power 0, and e raised to power 0 is, that is 1. So what is the remaining term? So equal to 0 to 2 pi I dt. So I dt. So I is a constant, so take outside of the integral, and derivative of integration of dt is t, and limits are 0 to 2 pi. So upper limit, lower limit, we will put upper limit and lower limit. So putting the upper limit and lower limit, we will get 2 pi I. So this is the value of the integral over gamma f of z dz equal to 2 pi I. Okay, so this is the simple example on a complex integral on result 1. Now we will see another example, that is here f of z is given as z to the power m, and where m is a integer, and gamma t is given as e raised to power it, where t lies between 0 to 2 pi. Okay, and here we have to show that integral over gamma z to the power m dz equal to 0. So we have to solve this problem. Okay, so solution. So given that is f of z equal to z to the power m, where m is an integer, and gamma of t also given that e raised to power it, where t lies between 0 to 2 pi. So this is the gamma curve. Okay, now we will integrate on both sides over the curve gamma with respect to z. So taking integration on both sides with respect to z over the curve gamma. So this can be written as integral over gamma z to the power m dz. Okay. Now here we will put z equal to gamma of t. So here we will put z equal to gamma of t. So integral over gamma of t power m derivative of gamma of t. But we know that gamma of t is given as e raised to power it. So we can replace gamma of t by e raised to power it, and integral will become convert 0 to 2 pi. Okay, so integral 0 to 2 pi, so this is the limit for t 0 to 2 pi e raised to power it power m, derivative of e raised to power it as it is. Okay, so here we have replaced gamma of t equal to e raised to power it. Okay, so this term can be written as 0 to 2 pi integral 0 to 2 pi e raised to power I t m into derivative of e raised to power it is e raised to power it into I dt. Okay, so we can club this term. Okay, so 0 to 2 pi integral as it is. So I, we can write here I e raised to power m plus 1. So take it is common, so we can write e raised to power m plus 1 into it and dt term as it is. So I is a constant, so you can take the out of the integral and derive, and then we will take the integration of this term. So integration of this term can be written as integral of I m plus 1 of t. So by using the formula divided by derivative of this term, that is I m plus 1 of t, derivative of this term m plus 1 of it, that is I m plus 1. Okay, and limits are 0 to 2 pi. Now we will take the upper limit minus lower limit. Okay, so here this I and this I will get cancelled. Now we will put the upper limit e raised to power I m plus 1 2 pi. Okay, instead of t we will replace the limits minus e raised to power 0, because t is 0, so this will term becomes 0, divided by m plus 1 as it is. So we know that e raised to power 0 means 0, e raised to power 0 means 1, and e raised to power I m plus 1 2 pi. So this will becomes 1. Okay, so 1 minus 1 divided by I m plus 1, so this will become 0. Okay, so this will becomes 0, and hence we can say that our result z to integral over gamma z to the power m dz equal to 0. Hence the result is proved. Okay, so this is the second example on a complex integration. Okay, so here we will see another example, that is third example. What is the third example? Third example is, let gamma of t equal to bt plus 1 minus t into a, where t lies between 0 to 1. Then we have to show that for any integer integral over gamma z to the power m dz equal to b to the power m plus 1 minus a to the power m plus 1 divided by m plus 1. So we have to prove this result for the given term gamma of t. So solution is, so what is given that? So we are given that f of z equal to z to the power m. Okay, because in this integral we can check this is the value of f of z. So therefore we can consider f of z equal to z to the power m. And given that gamma of t equal to bt plus 1 minus t into a, where t lies between 0 to 2 pi. Okay. So now integrate this term on both sides with respect to z or the curve gamma. So integral over gamma curve f of z dz equal to integral over gamma z to the power m dz. Okay. Now we will put instead of z equal to gamma of t, because z transferred to the curve gamma of t. So integral over gamma of t to the power m d derivative of gamma of t. Okay. So what is the gamma of t? We have given gamma of t is bt plus 1 minus t a. So put the values of gamma of t, and t lies between 0 to 2 pi, and integral will transfer 0 to 2, 0 to 1. So bt plus 1 minus t a to the power m, derivative of bt plus 1 minus t into a. So we will multiply it to this bracket. So this integral 0 to 1 can be written as bt plus a minus at power m b minus a dt. So what is the derivative of this with respect to t? So if you multiply this term, what is the derivative of this term? So derivative of this can be written as, so into a minus at. Okay, so derivative of this term will becomes b minus a dt. b minus a dt. If you calculate the derivative of this term, so you will get b minus a dt. Okay. So b minus a here is a constant term, so we can take outside of the integral. So integral 0 to 1. Okay, b minus a. So from this t we can take the common. So b minus a t plus a to the power m dt as it is. Okay. So to solve this integral, we use the formula integration of ax plus b to the power m dx. So which is given as ax plus b to the power n plus 1 upon n plus 1 derivative of ax plus b to the power ax plus b. Okay, so we will use this formula. So integral over gamma f of z dz as it is. So b minus a, this term is as it is. Okay, so term is b minus a t plus a to the power m plus 1 divided by m plus 1, and derivative of this term with respect to t, that is b minus a. Okay, and limits are 0 to 1. So here b minus a and this b minus a will get cancelled. So what is the remaining? And m plus 1 is a constant term, so we can take outside of the bracket. So integral over gamma f of z dz equal to 1 upon m plus 1 in bracket b minus a. So b minus a, we can put the upper limit. So b minus a plus a. Okay, power m plus 1 minus lower limit is, where is 0, then we will replace by upper limit and lower limit, 0 plus a to the power m plus 1. Okay, so here minus a plus a get cancelled, only remaining b to the power m plus 1, and here only remaining minus a to the power m plus 1. So this can be written as equal to b to the power m plus 1 minus a to the power m plus 1 divided by m plus 1. Okay, so we know that the f of z is z to the power m. So we can put here z to the power m instead of f of z. So therefore we can say that from this integral over gamma of z to the power m dz equal to b to the power m plus 1 minus a to the power m plus 1 upon m plus 1. So this is the required result of the given problem. Hence the proof of this problem is proved. Okay. So now we will see the another next rule, that is Leibniz rule. So we will use this rule to solve the next problem. So what is the Leibniz rule? So let us suppose that phi of st ab cross cd tends to c be a continuous function, and if g another function g cd tends to c, which is defined as g of t equal to integral a to b phi of st ds. Okay. So here then we can say that g is also continuous function. If phi of st is a continuous function, then another function is defined by g of t in this way, so that function is also continuous function. Moreover, if del phi by del t exists or phi of st is partially differentiable with respect to t, then g dash of t exists. Then g dash of t equal to integral a to b del by del t phi of st ds. Okay. So this is the statement of the Leibniz rule. We will use this Leibniz rule to solve the next problem. Okay. So you have to read this Leibniz rule. So this is a very most important result to solve the next problem. So in next period we will see some problems on a Leibniz rule. Okay. So here we will stop. We will see the problems on a Leibniz rule in a next lecture.